Hello, I'm Dr. Riri Januarti, and today I'm going to talk about the material and biophysics laboratories research facilities. This is a continuation of the first video, but this time we will focus on laboratory equipment that aid research in the field of material and biophysics. Okay, in the first video, I introduced a tool called XRD, and then in this video, I like to show you some of other tools available in material and biophysics laboratory, such as FTIR, UV spectrophotometer, AAS, XRF, and also SEM. And then let me show you one by one. Okay, the first one is FTIR. FTIR, or Fourier Transform Infrared Spectroscopy machine, is a tool used to obtain an infrared spectrum of absorption or emission of a solid, liquid, and gas. And FTIR spectrophotometer simultaneously collect high-resolution spectral data over a wide spectral range. This confers a significant advantage over a dispersive spectrophotometer, which measures intensity over a narrow range of wavelength at a time. Move to the next equipment, XRF. XRF, or X-ray fluorescence, is a tool used to determine the elemental composition of materials. XRF analyzers work based on the fluorescence or secondary X-ray emitted from a sample when it is excited by a primary X-ray source. Each of the elements present in a sample produces a set of characteristic fluorescent X-ray that is unique for the specific element, which is why XRF spectroscopy is an excellent technology for qualitative and quantitative analysis of material composition. Then, this is AAS. AAS, or atomic absorption spectroscopy, is a spectroanalytical procedure for the quantitative determination of chemical elements using the absorption of optical radiation by free atoms in the gaseous state. Atomic absorption spectroscopy is based on absorption of light by free metallic ions. Next, UV spectrophotometer. Ultraviolet visible UV spectrophotometer is a tool to measure light absorption across the ultraviolet and visible ranges of the electromagnetic spectrum. This tool works based on Beer-Lambert law. The amount of light absorbed is directly proportional to the concentration of the sample and the distance light travels through the sample. UV spectrophotometers is also able to determine the concentration of specific analytes in a microvolume by controlling the analysis wavelengths and the path length. The last one is SEM. A scanning electron microscope, or SEM, is a type of electron microscope that produces images of a sample by scanning the surface with a focused beam of electrons. The electrons interact with atoms in the sample, producing various signals that contain information about the surface topography and composition of the sample. The electron beam is scanned in a raster scan pattern, and the position of the beam is combined with the intensity of the detected signal to produce an image. In the most common SEM mode, secondary electrons emitted by atoms excited by the electron beam are detected using a secondary electron detector.